Okay, hi Danny. Welcome to lesson number 88. Today we are going to talk about remainders in stories about equal groups. So you already know how to do division with remainders. So we're going to be using that information. And you already know how to do word problems about equal groups. So we're going to put those two things together and work on a little bit more difficult word problems that talk about equal groups, okay? Here we go. Here is a little lighthearted math problem for you. It says Billy has 32 pieces of bacon. He eats 28. What does he have now? Happiness. Billy has happiness. Okay, so if you can achieve happiness with bacon, then it sounds like Billy has it. But we are going to move on to do the multiplication facts, okay? So get out your 64 multiplication facts. You're going to have 5 minutes to do it. On your mark, get set, go. I'm going to try and find some nice music. Maybe. Oh, that's an ad, sorry.
That is usually covered by her phone has finally made an
Okay. You're doing awesome, Danny. Keep going. Wow, I'm going to stop it right there, even though I could keep listening to that music for a long time. That was so beautiful. Okay. All right, let's jump into the rest of this lesson, okay? First, we're going to do mental math. This part is going to be easy for you. You are going to look like smooth avocado while you do this mental math, okay? Here we go. Mental math. A is 25 times 10. Write your answer. We're going to be looking at some people from the Grand Tour while we do this. He looks really excited about this problem. What's 25 times 100? Remember you're doing the same thing. 25 times 1. And then how many zeros do you add? There's 1, 2 zeros. Okay. And this guy's saying, sometimes my genius, it's almost frightening. I don't do a good English accent, though. You'll have to do that one for me. Okay, 25 times 1,000. So we're going to write 25 because it's 25 times 1. How many zeros do we add? Make sure you get that one right. All right, D. We're going to subtract $10 minus $6.75. I do not know what they're doing in this picture. It looks a little dangerous to me. E. What is 58 plus 35? F. What is 37 minus 19? Okay, now problem solving. And they're saying, when we get this sorted out, there'll be Nobel Prizes in it for us. There will be Nobel Prizes in it for us. I remember that episode. Okay, I'm going to move that out of the way, though, because it's distracting. Problem solving. We need to figure out, it's asking us what percent. So that's not a fraction, right? It's not, the answer is not going to be 3/4 or 5/6 or anything like that. It wants to know a number between 0 and 100 that you think is this pink part, okay, in my picture, or the shaded part in your picture. Okay, so let's take a look for a second, because if it was 50%, what would that look like? 50% would be like half of the circle is shaded, right? It would be maybe like all of this part was shaded. What would 75% look like? 75% would kind of look like that, where 75% is the same as 3/4. So 75% means you got 3 out of 4 problems right. 75%, that's what that would look like. So you just kind of estimate. You don't have to get it perfect, but I think it's going to be more than 75% based on what I see. In fact, the one in your book looks a little bit even more like that. So it could be more like that. Okay, so see, just take a guess. You know it's between something and something, so you take a guess. Alrighty, and then let's jump into the new concept, okay? So far we have already been doing equal groups problems, okay? And we solved those using division. In this lesson, we're going to be doing division with word problems, but now the divisions are going to have remainders. And so how does that work? It's not going to be equal groups anymore. It's going to be equal groups with a little bit left over. And so you're going to have to figure that out. And the hint to figuring out these problems is that you have to carefully identify what the problem is asking. Okay? That's the hint. You have to read it very carefully and figure out what they're asking. Okay? Here's an example. And here's another Grand Tour where they must have been racing with those trailers on the back, huh? That looks scary. Okay, I'm going to move that out of the way, though, because it's a little distracting. Example, the packer. There's a guy that's called the packer, and he puts bottles in boxes. That's what he does. The packer needs to place 100 bottles into boxes. Okay, so now we know he has 100 bottles. The boxes hold 6 bottles each. Okay, so I made a picture, found a picture of what that might look like. So here's a box. There, let's count the bottles. 1, 2, 3, 4, 5, 6. So it would look like this. Each box can only hold 6 bottles. It can't hold 7, but it could hold 5 or 4 or 3 or 2 or 1, right? You could leave part of the box empty. Okay, so the first question is, how many bottles can be filled? How many boxes can be filled? How many boxes? Not bottles, silly me. Okay, so how many boxes can be filled? So what did they tell us in the problem? They told us he has 100 bottles. Whoops, that's still doing a dotted line. I don't want to do a dotted line. Let's do it like that. Okay, so he has 100 bottles. And basically they want to know how many boxes can you fill. So what do we do to figure that out? We're going to find out how many bottles per box, and there's 6 of them. So if there's 6 bottles per box, then we have to divide 100 bottles by 6, because there's 6 bottles per box. You haven't learned how to do this yet, but the units here actually cancel out, and box will go on top, and this will tell you how many boxes he needs. But that's okay. This is more algebra, but that's how my mind thinks right now because I'm helping Zach with algebra. So that's what I have to do. Anyway, I think you know you have to divide 100 divided by 6. So I need some more space to do this. Okay, let me find the space. I'm just gonna erase this and I'll tell you the other parts of the problem. Okay, here we go. 100 divided by 6. So 6 does not go into 1, so we're going to go to the next digit. Does 6 go into 10? Yes, it does. It goes 1 time, because once you have 2 times, then you're at 12. So then we multiply. 1 times 6 is 6. So I'm going to write that here. 10 minus 6 is 4, because we subtract, remember, and then we bring it on down. We bring down the 0. How many times does 6 go into 40? Well, I know my times tables. 6, 12, 18, 24, 30, 36, 4, oh, and then you go way past 40. You go to 42. So it has to be 6. Okay? And then I multiply. 6 times 6 is 36, and then I subtract. 40 minus 36 is 4, and there's nothing to bring down. So the answer is 16, remainder 4. Okay, 16 remainder 4. So what were we trying to figure out? We were trying to figure out how many boxes can be filled. And what that number means, 16 remainder 4, is you can fill 16 of these boxes perfectly, but then you're going to have 4 bottles left over. 4 extra bottles, okay? So 16 remainder 4. All right, so how many boxes can be filled? We have to closely identify what they're asking. How many boxes are going to be full? If they want to know how many boxes are going to be full, then we ignore the remainder for now. And the answer there is going to be 16. 16 boxes will be full, okay? Okay, now B, it says the next question was, so let me erase this question now. It wants to know how many bottles will be left over. So bottles left over. So that's where your remainder comes in handy. The remainder tells you how many extra bottles you're going to have because they didn't fill that last box. Think about it. If this were remainder 6, you could put another box. You could put those in another box, but there's only 4. So there's no way the remainder will be more than 5, right? It could be 4 or 5 or 3 or 2 or 1, but if you have 6, that's going to fit into the box. So there's no way you'll get a remainder 6. So the bottles left over, that's going to be your remainder. That's 4. Okay. The last thing that it's asking us is how many boxes are needed to hold all the bottles? Well, here's what it's saying. You got to do something with those 4 bottles. You can't just send 4 bottles in the mail like that. You got to put them in a box too. They need a home, right? So what you're going to do is you're going to get 1 extra box and put 4 bottles in it. 1, 2, 3, 4, and leave 2 empty spaces. So then instead of having 16 boxes, you're actually going to need 17 boxes total. One of them's going to be partially empty. One of them's only going to have 4 bottles in it. Does that make sense, Danny? That's the important part to remember of these problems. Okay, so 17 boxes are needed to hold all of them. So that was, but guess what? I didn't think that was enough examples for you today. So I'm going to do the first problem in your lesson practice, and we'll do it together, and that'll be great because you'll start to get the right answer. I hope I do it right? If not, you can be like, I hate you. I got it wrong because of you. Okay, but here we go. Lesson practice. The first problem in your homework says, tomorrow, 32 employees are going to a conference. Okay, so that means 32 people that like work for a company or something. They're all going to a conference, maybe to learn something. But each car, and they're going to provide transportation for these people, so that's cool. Each car can carry 5 employees. Yeah, we know 5 people can sit in the car, 2 in the front, 3 in the back, right? Okay, so each car can carry 5 employees. How many cars can be filled? That means all the way full with 5 people. How many cars would you need? So to figure that out, that's a division problem. It's going to be 32 employees divided by 5 because you want them in groups of 5. 32 divided by 5. That's the same as this kind of problem. Okay? And I'm going to move this out of the way so I have more space. So how many times does 5 go into 32? Okay, so if you know your five times tables, 5, 10, 15, 20, 25, 30, you'd get that when you get to 6. So 5 goes into 32 6 times. And then we're going to do 6 times 5 is 30, right? So we write our 30 here, then we subtract, and there's 2 left over. And there's nothing to bring down, so that is just our remainder. So the answer is, I'll put that, whoops, the answer is 6 remainder 2. So what does that mean? They asked us how many cars can be filled. 6 cars can be filled, but there's 2 extra people that are not going to get a ride. But the answer to A is still 6 cars because 6 cars can be filled because there are 6 groups of 5. And then in B, it says how many cars will be needed. So that's important that the way they asked that, they said how many cars will be needed. Well, guess what? You can't make those last 2 people walk. So you need 1 extra car for those last 2 people. So it's going to be 6 cars plus 1 that's only going to have 2 people in it. And you need a total of 7 cars to get all the employees to the conference because you can't make these 2 people walk. That might be a long way. That's crazy talk. All right, so there's another word problem for you to do after this about quarters and stacks of quarters, okay? So you do that one, and then you are done. Well, you gotta do the rest of your math homework, all the review and everything else. But you're gonna love it. You're gonna be as excited as this guy to do it, okay? Have fun doing your math, Danny. Love you. Bye.